Hey guys, what's up? This is Swati Sneha and you're welcome to my YouTube channel Big Data Online School. In this video, we are going to Sqoop performance tuning, where we will see how to tune your performance for import part, for export part in detail. So let's get started. If we look into performance tuning in Sqoop, we can say that there are many ways in which we can do performance tuning for Sqoop. First of all, we'll proceed for import performance tuning. Basically, we have seen what actually import is and how we used to perform. We have seen workouts also, some of the hands-on experience we got for import thing, export thing. So after performing all the operations, now we should learn how to tune your performance. All right. So the first and foremost part is definite number of mappers. As you know that what mappers is and how to use mappers, we can assign or we can launch mapper as -m or -num mapper like that. This way we are going to assign mapper. Let's say if we are going to assign 3 number of mappers, then we have to write -m3. Actually, what happens is mappers help us to improve our performance in both import as well as export. It will allow our jobs to run much faster, as many mappers lead to launch of corresponding number of threads for parallel task execution. As we have seen in our architecture part, as many number we are increasing for number of mappers, the same thing is going to, the number of thread is also going to be increased and parallel task execution will be there. We have seen if we use only single thread for high volume data transfer, it will take a hell lot of time, right? Hence, Sqoop has a property to use multiple threads, which leads to performance tuning as well. You can take a note here that increasing more number of mappers will affect our performance as well. It's not like if we have much data or if we have many records present, so let us do that more. Let us use more mappers. It is not like that. Increasing more number of mappers will affect our performance as well. So the recommended number of mappers are like 12 to 16. That is the maximum if it is needed. All right. So the recommended thing that we have to use mappers, the number of mappers should be 12 to 16, but not more than these mappers we should use, because as you know, for each and every mapper utilization, it is going to create a session in our relational database. All right. Let me tell you an example. Let's say if we have 10 developers and they are going to execute the code in production by launching 2020 mappers each, then we can say that 10 into 20, that is 10 number of developers are going to launch 2020 mappers. That means that 10 into 20 equals to 200 connections would be made with database at a time. Alright. If developer makes 200 database connection at the same time, this may affect the performance of database. Right. So DBA, like database administrator, used to take help of a queue called delay queue. If they find that many number of users are logged in and want to make a connection with database, this way they maintain performance of database. Alright, there should not be many number of mappers, there should not be less number of mappers, it should not be like that. So the next question would be like, on what basis we can define the number of mappers? Like how can we define what number of mappers should be launched? Right, this must be the question of yours. The explanation will be like, if we have huge amount of data, then increase the number of mappers. Right, we think like that only, but that should not, like that should come under recommended range only. That is from 12 to 16 we can launch our mappers in the range of 12 to 16. But again, we have to consider type of data and size of data. It's like if we have large amount of data, alright, or if we have some different kind of type of data, we have to consider these two things in order to launch number of mappers. Only considering size of data won't be going to help us in performance tuning. Alright, it's like, let's say we have 1 lakh records. Okay. For transferring of data that contains 1 lakh records, we can use 4 mappers. And let's say we have 1000 number of records. For transferring of data of 1000 records, we have to use 10 number of mappers. Why is it so? Let's say assume that 1 lakh records has 8 columns in its table and 1000 record data has 160 columns in its table. So here you can see that since the number of records is much in 1 lakh records, compared to 1000 records, right? But the number of columns that is present in 1000 records, that is 160 columns, is much more than the first one, right? So in this case, we are using more number of mappers, that is 10 number of mappers. This way you can refer here, like we should not consider only size of data to decide what should be the number of mappers. Instead, we should consider both the things, type of data and size of data. Therefore, we have to use number of mappers wisely whenever it is required. Alright, the next part is use direct mode for all available databases. As we have already seen in our theory part, like what direct mode is, how we used to like connect to JDBC driver, and if we have direct mode available, like native utility is available for certain databases, then how can we use that? Like, as you know that some of the databases supports direct mode, right? Like we have done for MySQL and some other also like Oracle, Netezza, Postgres, etc. These are supporting direct mode also. But many databases are there that doesn't support direct mode. In that case, we have to rely upon JDBC connector to pull the data, or you can say to export the data. If you use direct mode, this direct mode, that is hyphen direct mode, you will see significant difference in time taken to transfer the data. Alright, but and on the other hand, there are few disadvantages also. There are few limitations also that direct mode doesn't support. Like some of the things that direct mode doesn't support if we are using it for transferring of data, like escape character, or maybe type conversion columns, or maybe some of the row delimiters, binary formats. These are not supported if we are going to use direct mode. In order to use this direct mode, we have to avoid this. So these are the limitations for direct mode. Rather than using JDBC interface for transferring data, direct mode delegates the job of transferring data to native utilities provided by database vendors. It's like native utilities already embedded with databases. So instead of using JDBC driver, if we have that kind of database that has that native utility and that can be used by us, so it's better to use the native utility and avoid the third-party JDBC connector in order to get high performance. Alright, therefore in nutshell we can say that if we use native utility of database instead of using JDBC drivers for transferring of data, performance will be much improved. Alright, so the third performance tuning part for import is splitting the data, that is using split by and boundary queries. What actually boundary queries is, let's say if our database table doesn't have any you can say primary key column or any index, then Sqoop we will generally use natural key column to divide the task into mappers, right? So this is done by split by option, right? But if you don't have primary key in the table and DB is not having any optimum performance, in that case you have to use boundary queries. How can we use boundary queries? It's like hyphen boundary and then hyphen query. If we write this, then there we can write our customized query, right? Let's say if we use split by option, what we have to write, hyphen split by, and then any of the like ID that is as primary key, you can say employee ID, customer ID, anything. What happens is it will execute a query in the backend if we write the split by option. We have already discussed in the study part. Let me explain it again. If we write split by and then employee ID, what happens? It will execute a query in the backend as select minimum of employee ID, maximum of employee ID from employee table, right? And according to the maximum and minimum value, it will assign number of records to each mapper. This is for the simplest case, that if we have only one table and we are not going to customize our table or no complex data are there. But if we have to import a customized set of data, a complex set of data, like we have to join first 2-3 tables and then we have to transfer or we have to import the data, the kind of complex scenario, in that case we can write boundary query to reduce complexity. So how is it like? Let's say we have to join two tables called employee table and its employee order table. Alright, so that we can write here in query hyphen query, and then we can write that whole of the command to join two tables, employee table and employee order table. Right. And now in order to get the boundary condition, that is minimum and maximum. Now we have to use consolidated version of those joint tables, right? Now we don't have only one table that we can use split, but now we have a complex query that uses 2 or 3 tables. So here in this case we can use this boundary query, and there we can find select minimum of ID and maximum of employee ID from the table. Alright, therefore we can say for any complex data, boundary query is more sufficient and performance is really improved with the help of this boundary query. Next performance tuning part is using conditions. This condition is nothing but you can say as it is as filter. By writing these conditions, I am asking Sqoop to put filter condition according to our wish. Assume we have 30 records, okay, in an employee table. So how it will divide? It will divide as mapper 1 should take record from 1 to 10. Mapper 2 will take record from 11 to 20, and then mapper 3 will take record from 21 to 30. This way I am asking Sqoop to filter the condition according to my wish. If we write a free form query like hyphen query, how we used to write, our system will automatically assign mappers the task to be performed. Here you can see that the task to be performed by each mapper is automatically assigned, and hence it helps in taking less execution time. So this way we can say that using condition, that dollar condition thing in our import, this will improve our performance. So these are the techniques, these are the methodologies that we can use in our query to improve our import performance. Alright, next we'll proceed for export performance tuning. So here also for export performance tuning, we should make sure that definite number of mappers are used. The same way that we have used, like we have to take in consideration the size of data and the type of data, all those things that we have discussed in our import performance tuning. Next we'll go for batch mode. Batch mode is nothing, you can say that rather than like exporting data record by record, we can export number of records in a batch. Instead of exporting data line by line or one by one, we can export data in a bunch, or you can say in a batch, you can say. Okay, as you know that like generally Sqoop export row by row data only, right? But if we don't leverage batch mode option, but enabling like batch mode, this will export more than one row at a time as batch of rows. This way what happens is, so let's say if we have 100 records and if we are aligning 10 set of records at a time, it will just take 10 times, like let's say if 10 record is going to take 2 seconds of time, then to transfer data of 100 records, it will just take 20 seconds of time to be transferred. But if it is taking 1 second for each record to get transferred, then it will take 2 into 100, that is 200 seconds of time to be transferred. Like you can say export the data from our HDFS to our database, right? So this way performance is improved if we are using batch mode. Next comes to specify number of records to export. This means that this option will define number of rows in each insert statement. Let's say if we are going to write insert query, okay, like insert into table, that whatever the value that we want to write. So what happens is, how to specify number of records. It's like we are going to write -d Sqoop export records per statement equal to 10. This means that for one statement of insert, I am going to export this 10 number of records at a time. So imagine if it is like that, then how much time we are going to save to export that data, right? So this is the best part, like this is really amazing part for performance tuning in export. Next part is specify the number of records per transaction. It means like if we write this -d Sqoop export the statement per transaction equals to 10, it will help us in taking less time to execute the query. Like for per transaction equals to 10, we are going to put it as a, you can say as a bunch, it is like that. So this way it is again something amazing to get the transaction equals to 10 at a second, right? So this way export like performance tuning is like we can say the export performance is improved, right? Next is data consistency. Data consistency is nothing but we are going to create a temporary table called staging table where we are going to put our data first in order to avoid dirty data reading by Sqoop. As you know that Sqoop doesn't read any dirty data, it reads only committed data. So to avoid reading dirty data by Sqoop, we are going to use staging table where we can write hyphen hyphen staging table and then the table name. As we have discussed in our theory part, like we had 1 lakh of records, okay, and we were using 3 number of mappers to get the data from our, we can say from our relational database to our main table in SDFS, it takes little time. If two or multiple users are going to check the number of count of records in few interval of time, it will get dirty data, right? So in order to avoid those dirty data, what we are doing, we are like we are creating a temporary table in the mid where all the SDFS data is going to be transferred to first staging table, and then within a few seconds that staging table's data will be going to relational database, and this way Sqoop will avoid reading all the dirty data and it will only read committed data. Hope you guys understood this export performance tuning part and import performance tuning also. Next we have some miscellaneous Sqoop options. This is very important for interview point of view. Let's say if we want to write our own query and if we have some our personal customization for any of the like transferring of data, we can do Sqoop evaluation where we have to just put eval in the front part instead of you like we were doing Sqoop import or Sqoop job. Just instead of that we have to write Sqoop eval and then connecting to JDBC into MySQL under distance database, we are going to put our username and password, and then we can write any free-form query here. As you can see, I have written as hyphen hyphen query and then select start from employee. This means that I can do all the evaluation of like according to my wish, and I will get all the data from my database. Next is batch export, as we have seen that per transaction export and per statement export in our performance tuning part. So the same thing it is here also. Next is code generation, that it is also very helpful for us, this code generation part. It's like if we have to do that code generation part, just like replace this eval into code generation and the query would be same like connecting to JDBC driver and then using this sales database and then putting username and password and get the data from employee table. So this way we have completed our Sqoop part where we have seen all the theory, architecture, properties, and then we have seen all the workouts hands-on of Sqoop, and then in this video we have completed our Sqoop performance tuning. So this way we have completed our Sqoop part and we'll go for some other tools in our next videos. Thank you for watching.